Hello friends, you are welcome. It's Dr. Cliff. Today we are going to be looking at how to write a equilibrium constant expression. Okay, there are 5 rules that must be meticulously observed when writing a equilibrium constant expression. 5 rules must be carefully observed. Okay, now this aspect is very important because it shows up in our exam every now and then. So it becomes highly imperative for us to get ourselves acquainted with the rules. Now let's get started. Now on the board I have 5 rules. Now rule number 1, rule number 2, rule number 3, rule number 4, and rule number 5. So we are just going to get ourselves familiarized with these rules as we, discuss the various rules. Now rule number 1 says, write the balanced chemical equation for the equilibrium reaction. So now, how does that make sense? Now, for example, when you are given a particular equation and you are asked to write the equilibrium constant expression for that reaction, for that equation, what you simply do is to look at the equation if it is balanced or not. So if the equation is unbalanced, then you have to balance the equation. So that is the very first rule, okay, that must be carefully observed. Okay, so that is the very first rule. Now going to the rule number 2. Rule number 2 says, write the product of concentrations of the product and the product of concentrations of the reactant. So what does that mean? What does that mean? Let me quickly show you that. So what that simply means is that, okay, imagine I have, okay, so write the product of concentrations of the product. So the product of concentrations of the product, what does that mean? It therefore means that I will be having product of concentration, so we'll be having something. Okay, let's say I have A plus B, C plus D, C plus D. All right, so here is 4, here is 3, and here is 2. Okay, these are potential equation. Okay, all these species are in the aqueous form. All right, so now we're asked to write the equilibrium. We're asked to, if we're asked to write the equilibrium constant expression for this equation, what do? Now the rule 1 says, you have to what? Balance the equation. You have to write a balanced equation for the reaction. So rule 2 says, write the product of concentration of the product. So write the product of concentration of the product. The concentration of the product. How do we go about that? We're just simply going to say, write the product of concentration of the product. Okay, what that means is, I'm going to do something like this. So the product, so these are the products, then these are the reactants. All right, so for the product, I will simply say concentration of C, concentration of D. Now, in case you don't know what this means in chemistry, this represents what? Molar concentration. Okay, molar concentration. So molar concentration, that is concentration in mole per dm cubed. Concentration in mole per dm cubed. So this is a symbolic representation of molar what? Concentration. That is concentration in mole per dm cubed. So what I simply do here is to say, so this is the what? Concentration of C. This is the concentration of D. So that is basically what I have here. Okay. So writing for that of the reactant, I'm simply going to say, okay, it's still the same thing. I will simply say A, concentration of A, and concentration of B. Okay, so you can see this is how I've written. This is simply going to be the what? The product. Look at it. This is the product. Okay, so I've written the product. Multiplication is product. So this is the what? Product of concentration of the what? Of the product. and this is the product. Okay, product means multiplication. This is the product of what? The concentration. You know, I told you this symbol represents what? Concentration. So this is the product of the what? Of the concentrations of the what? Of the reactants. Okay, so I'm going to call this product what? Concentration. I'm going to call this reactant concentration. All right, so I'm done with that. Now, having said that, so you can see I've carefully observed rule 2, which says write the product of concentrations of the what? Of the products. Okay, I have done that. And the product of concentrations of the reactants. So this is the product of the concentration of the product. Why this is the product of what? The concentration of the what? Of the reactants. So we have observed rule number 2. So let's now observe rule number 3. What does rule number 3 say? Rule number 3. The coefficient in the balanced chemical equation becomes the exponent in the equilibrium constant what expression. Now, what does that imply? What does that imply? So if you take a look at this equation, okay, the coefficient of A is 1. Okay, there is 1 here. Okay, you know you don't need to write 1. Okay, but just know there is 1 here. So the coefficient of B is 4. The coefficient of C is 3. The coefficient of D is 2. So the coefficient now becomes the what? Becomes the exponent in the equilibrium constant expression. It becomes the exponent in the equilibrium constant expression. Now, what do we mean by that? So I'm going to write in the place of C, what is the coefficient of C? 3. So it becomes the word exponent in the equilibrium constant expression. Now, what is the coefficient of D? Is 2. So it becomes the word exponent in the equilibrium constant expression. Now, what about A? A is 1. Okay. So, and what about B? B, the coefficient of B is 4. So it becomes what? You know, the exponent in equilibrium constant expression. So we have carefully observed rule number 3. Now let's take a look at rule number 4. What does rule number 4 say? Now, rule number 4. The equilibrium constant expression is then written by placing the product concentration with their exponent in the numerator and reactant concentrations with their exponents. Okay, with their exponent in the what? In the denominator. Okay, in the denominator. Okay, that's going to be in the denominator. Okay, in the denominator. All right, in the denominator. Okay, so now what do I do? Now let's get that done. Okay, let me rub this off. Okay, so let me also rub this off. Now I'm going to be having K. So K is indicative of what? Equilibrium what? Constant. So equilibrium constant is going to be product concentration all over what? Reactant concentration. Product concentration all over what? Reactant concentrations. All right. So what do we do? K means equilibrium constant. Okay, K is indicative of equilibrium constant. So K becomes, what is the product? You can see this is the numerator. This is the denominator. Okay, numerator, denominator. Okay, now what will be placed on the numerator is going to be the product concentration. So that is what rule number 4 is talking about. Okay, so that's what rule number 4 says, that the equilibrium constant expression is then written by placing the product concentrations with their exponents. You can see with their exponent in the what? In the numerator. So I'm going to place it in the numerator. So where I'm going to have this C raised to raised to the power of what? Raised to what? 3. Then I have D to, so all over the reactant concentration, where I have A, what's the exponent? 1, and B, the exponent is 4. So this is what we basically have. So this is going to be the equilibrium constant expression for this what reaction, for this equation. All right, so this is how we go about it. Now if you take a look at these chemical equation, you will discover that all the species involved are in the aqueous form. So now let's come to rule number 5. Now, rule number 5 says liquid and solid do not appear in equilibrium constant expression. Only gaseous and aqueous species are represented. So what does that mean? That simply means that whenever you see a solid, whenever you see a liquid, do not represent them in equilibrium constant expression. Now, they are usually omitted. Okay, they are usually omitted, okay, from the equilibrium constant expression. So let's say I take here to be solid. Let's say B is solid, okay, no longer aqueous. So it therefore means that B will go, the concentration of B will go. So we now have just A. So it's going to become like so. This is what we now have. So we now have this. All right. So this is what we now have. So I can write this as this. So A, concentration of A, like this, like so, is the same as, this. So this and these are the same. So whether I write it like this or like this is the same thing. Okay. So this is what we now have as our equilibrium constant expression when B, okay, when B is a solid. Okay, we now have something like this. So, okay, you're asking why liquid and solid do not appear in equilibrium constant expression. Why do they not occur? Why do they not appear in equilibrium constant expression? The reason why they do not appear in equilibrium constant expression is simply because solid and liquid, the concentrations do not vary significantly. Okay, the concentrations do not vary significantly, so they are usually not varied. The concentration is usually not varied. Okay, it doesn't vary significantly. Hence, the concentration is going to be what taken as, is usually taken as 1. Okay, it's usually taken as 1 unity. Okay, so imagine if B as a solid, we say B. Okay, this B here, which used to be like this, now we're going to take it to be 1. Okay, now if we put this times 1, it's still going to be this. So we take the whole of this as 1. So the concentration does not vary. It does not vary significantly. Hence, we take it as what? As 1. Okay, so we take it as 1. So that's the reason why they usually do not appear in equilibrium constant expression. So that's the essence. That's the reason why they do not appear in equilibrium constant expression, in case you're asked in your exam. Okay, they do not, solid and liquid do not appear in equilibrium constant expression. We are going to take some questions, some exam questions. You're going to see that sometimes they will give you chemical equations where you have some of the species in the solid and liquid state. So you are expected to know that solid and liquid do not appear in the equilibrium constant expression. Only gaseous and aqueous species are represented in the equilibrium constant expression. All right, let's get down with some questions. Okay, now I have a question here. And it says, this is Cu copper nitrate. So giving us copper 2 oxide plus NO plus oxygen. All right. So this gas, this solid, and this is solid. Now we're asked to write the equilibrium constant expression for this equation, for this reaction. So how will you write the equilibrium constant expression for this reaction? Now, I know some of you might be tempted to just come here and say product over reactant. Okay, product concentration over product concentration all over reactant concentrations. This is the formula, right, for equilibrium constant. Okay, now, but before you do this, I shouldn't come here and start putting all this. I shouldn't come here and say this is the product. I put the product here, the product concentration. I come here, the reactant concentration. No, I shouldn't go ahead to do that. That shouldn't be the first thing to do. Now, the very first thing to do, according to the rules that have been discussed, the rule number 1 says you have to balance the what? The equation. You have to check whether the equation is balanced or not. If the equation is not balanced, if the equation is unbalanced, then you have to balance the equation. Now, take a look at this. Here, copper is 1. Here, copper is 1. Okay, let's say copper is balanced. Here, nitrogen is 2. Here, nitrogen is 1. It tells us copper is not balanced. Here, oxygen is 2 times 3, that's 6. Oxygen is 6 here. Here, oxygen is what? 1, 2. 2 plus 2, that's 4. Oxygen is 4 on the what? On the right hand side. So you know that balancing of chemical equation means that the right hand side must be equal to the left hand side, isn't it? Good. That is what a chemical equation, that is the rule that must be observed. Now, coming here, it tells us that this equation is unbalanced, so we have to balance the what? Equation. Okay, so what do? We have to balance. You have to put 2 here. So copper here is 2. So copper here has to be 2. Copper now is balanced. So nitrogen is what here? Nitrogen is 2 here. 2 affects this. So here nitrogen should be 2. I place 2 here. Okay, wait a minute. Okay, what about oxygen? Oxygen is 3. 2 times 3 is 6 plus 2. That's 8. Here oxygen is 8. Okay, because I have 3 times 2, 6 plus 2, 8. So here oxygen has to be 8. So which means here oxygen is already 2 and here oxygen is 2. That's 4. So which means I have to put 4 here. I have to put 4 here so that nitrogen is how many? 2 plus 2. Oh, nitrogen is 4 now, right? So nitrogen is balanced. Okay, nitrogen is balanced. Now nitrogen is balanced. Okay, this is a balanced equation. All right, now let's balance this is a balanced equation. Now let's write the equilibrium constant expression. So the equilibrium constant expression, now the other rule that must be observed is that the last rule, which is rule 5, is still here staring at you. Rule 5 says liquid and solid do not appear in equilibrium constant expression, which means that we are going to omit this. This is not going to appear. This is not going to appear. All right, so we are just going to say that equilibrium constant is going to be what? Just these 2. Only these 2 are going to be considered. Okay, that is NO. So NO raised to power what? So which means if I come here, okay, let's say I write it. I will say CU. Okay, I will start with the word the product, isn't it? CuO. Let's write, first of all, you write for the product concentration CuO 2, then NO 4, then O2, then all over, let's see, all over what? Then this is the reactant concentration, right? This is the reactant concentration. These are the what? Product concentration. So I will put CEO NO3, then 2, So raised to power 2. Okay. So this is basically what we do, right? So you know that this shouldn't appear because it's solid. Okay. And I'm going to stroke it. And also, who shouldn't appear? This shouldn't appear. I'm going to stroke it. So which means what we are going to be having is going to be K equals to just these two, right? NO4 O2. So this is what we're going to be having. This is going to be our answer. This is our equilibrium constant expression. Okay, this is our equilibrium constant expression. So this is how to write equilibrium constant expression. Okay, now let's take one more question. Let's take one more question. Let's take one more question. Here I have FeO plus water, then solid, I think, liquid. What will this give us? This is going to give us Fe what? This is going to give us Fe, Fe2O3 plus H2 gas. I think this is solid. All right. So we are asked, if you're asked in your exam, write the equilibrium constant expression for this reaction. What do you do? How do you go about it? It's still the same thing. Don't forget rule number 1. Now, what does rule number 1 say? Now, you have to check, is this equation balanced? Now, let's see. Iron here is 2. Iron here is 1. Iron here is 2, right? So what do? We have to put 2 here to balance the iron. So iron is balanced now. What about oxygen? Oxygen here is 2 because this 2 is affecting it. 2 plus 1, that's 3. Here, oxygen is 3. Oxygen is balanced. Now, what about hydrogen? Hydrogen here is 2, and hydrogen here is 2. So the equation is balanced now, right? So the equation is balanced. Now, what do we do next? The next thing is to consider the solid species. We have already identified this, and this is liquid. Remember, we said solid and liquid. Liquid and solid do not appear in equilibrium constant expression. Only gaseous and aqueous species are represented. So what do? So when we are writing the equilibrium constant, so this is the reactant. These are the reactants. Why these are the what? Are the products. So the products. So K is going to be product concentration. Product concentrations. Don't forget this formula. All over reactant concentrations. Okay. Don't forget this formula. All right. Now, what is K? K is going to be what? Now, product concentration. This is my product concentration. That is Fe2O3. So hydrogen all over product concentration all over reactant concentration, which is FeO, then H2O. So don't forget that solids and liquid should not appear in equilibrium constant expression. So which means this should not appear, this should not appear, and this should not also appear because they are solid and liquids. Okay, so this is solid. I'm going to stroke it. This is solid. This is solid. I'm going to stroke it. This is what? Liquid. I'm going to stroke it. So the only gaseous species here, the only species here that can be represented in equilibrium constant expression is hydrogen. So I would say that K is equals to concentration of hydrogen. So this becomes our answer. So this becomes our answer. So this is our equilibrium constant expression. So when you are asked to write the equilibrium constant expression for a reaction like this in your exam, so just take note, this is how it is done. This is the application.